The equation that we ended the last video with can be simplified to v1 prime times y1 prime plus v2 prime times y2 prime equals f over a, where f is the right-hand side of our original differential equation and a is the leading coefficient. Now, combining this requirement with the requirement that we set to simplify yp prime, we get the following system of equations. Now, we get v1 prime times y1 plus v2 prime times y2 equals 0. And then v1 prime times y1 prime plus v2 prime times y2 prime equals f of a. Now, important to note here is that the unknowns in this system of equations are v1 of t and v2 of t. Right? We have y1 is known, y2 is known, then y1 prime is known, y2 prime is known, f is known, a is known. So we have two equations and two unknowns. So we have some hope that we can solve this for v1 prime and v2 prime. Sorry, should have said that v1 prime and v2 prime are the unknowns here. Now, in order to do this, we need to recall the Wronskian of the functions y1 and y2, which is given by y1 times y2 prime minus y1 prime times y2. Again, note here that the Wronskian can also be written as a determinant of y1, y2, y1 prime times y2 prime. And the determinant of a 2 by 2 matrix is y1 times y2 prime and then minus y1 prime times y2. Now, by using some linear algebra, we can show that the solutions of this system of equations are given by v1 prime equals negative f times y2 over a times the Wronskian of y1 and y2, and v2 prime is f times y1 over a times the Wronskian of y1 and y2. Now, we always have to worry a little bit when we divide by something that we're not dividing by 0. Well, note that the Wronskian of y1 and y2 is not equal to 0 because y1 and y2 are linearly independent. y1 and y2 are linearly independent. Now, we can find v1 and v2 by integrating these two expressions right here. And if we summarize all of that, it leads to the method of variation of parameters. So to determine a particular solution to ay double prime plus by prime plus cy equals f, we find two linearly independent solutions, y1 and y2, to the corresponding homogeneous equation or homogeneous equation. Then we find the Wronskian w of y1 and y2, which equals y1 times y2 prime minus y1 prime times y2. And then in the third step, we find v1, which is the antiderivative of f times y2 over a times the Wronskian of y1 and y2, and v2, which is the antiderivative of f times y1 over a times the Wronskian of y1 and y2. And then finally, a particular solution is given by yp of t equals v1 of t times y1 of t plus v2 of t times y2 of t. We will do some examples in the next two videos.